Thank you all for being here at UIKonf, and thanks for coming to my talk on state-driven development, the beauty of Enums in Swift. My name is Conrad Stoll, and I'm a software engineer at Under Armour. I work on the MapMyRun and MyFitnessPal apps for iOS and Apple Watch. Like many iOS developers, I love building apps with Swift, which is why I'm here to talk about my favorite Swift language feature, Enums. A lot of people notice Enums pretty quickly when exposed to Swift. They're arguably one of the most powerful Swift language features, and many of us have probably used Enums in other programming languages too, possibly without even realizing it. But I think that Enums in Swift are so powerful that they're worth designing software around, just like object-oriented programming and protocol-oriented programming. I think of it as state-driven development, and that's what this talk is really all about. But before we get to Enums, we need to start with a different programming tool that we're probably all even more familiar with. It's something that we probably use every day while writing code. Bool. Specifically, bools used as instance variables that represent the state of an object. They're actually a tool that we use all the time. We define these properties on objects we create ourselves, often out of convenience, or we set these properties on other objects that we interact with. So how often do we use bools? We can use a regular expression to search our Xcode project for this pattern and see what all of the examples look like. In the Project Find Navigator in Xcode, select regular expression from the dropdown and enter the pattern you want to match. If your project is anything like mine, you'll probably be pretty surprised at what you find. Here's just a few of the examples that I found in one of my projects. Some of these seem fairly clear in terms of what they mean and when they should be true or false. But the problem with bools is that it's not always clear what they mean. How often do their values change, and who is responsible for changing them? How do different bools relate to each other? For example, when one bool is true, should another bool be false? Let's go through an example together. We're working on an app for tracking workouts. The app has one purpose: to allow the user to track a workout. When the user opens the app, they can always start a workout. So imagine there's just a giant button that says Start Workout. So we write a function that starts a workout when the button is tapped. And this works great, but later on we realize that our app can start two workouts if the button is tapped twice. How do we prevent that? We add a bool to represent whether or not a workout is in progress. Now we can guard against starting a second workout if the first one hasn't finished yet. And this also works great for a while, but then we realize there's another requirement missing from this method. If a user hasn't logged into the app yet, then they won't be able to save their workout. To prevent that from happening, we add another bool to track whether or not the user is logged in. We expect this property to be true when the user logs in, and we add another case to our guard statement to make sure it's still true. Now the user has to be logged in to start a workout, and we can only have one workout running at a time. This is getting pretty complicated though. First, we need to trust that something we'll set has logged into true. We also need to set workout in progress back to false at the end of the workout, or we won't be able to start another workout later. The potential for bugs to creep in has gone up quite a bit just from adding one more variable. Now we receive another requirement for our start workout method. We want to prevent starting a new workout while we're in the middle of saving the prior workout, so we add a new variable to track if we're currently saving a workout. And this is where the web of state starts to get very tangled. First, we set workout in progress equal to false, since we've stopped tracking the workout, but saving the workout is an asynchronous task, so we set the saving workout variable to true when we start saving, and back to false when we finish saving. Back in our start workout method, we add a third case to our guard. The user still has to be logged in, and they can't start a workout if there is a workout still in progress or being saved. But that's turning into a really long guard statement. There's a lot we need to remember to do as programmers to make sure that all of these variables operate the way that this function expects them to. So here's what's crazy about this. We have 3 bools, but our app can actually be in 8 completely distinct states. even though only 4 are actually valid. These are the 4 combination of values that are valid. They follow the user's expected path through the application. The user logs in, starts a workout, and saves the workout. But with bools, we can represent combinations of values that shouldn't be possible. These 4 combinations represent potential bugs. They are states we could accidentally find ourselves in if we fail to update our bools correctly. Something like the user not being logged in, but still having both a workout in progress and another workout being saved. This is the perfect case for creating an enum. We have 4 valid states that we've identified, and we know our object should only ever be in one of these states. We need to construct an enum that shows exactly which of those 4 states our object is in. These are the 4 valid states. The user hasn't logged into the app yet, they're in the middle of a workout, they're saving the last workout, or the app is idle. And here's what they look like as an enum. We have the 4 cases: not logged in, workout in progress, saving last workout, and idle. One of the benefits of using an enum instead of multiple bool values is that we've actually made the invalid states impossible to represent in code. But our job isn't done yet. Even though we've created an enum to accurately describe the state of our object, we still have to update our code to ask specific questions using the enum that we've defined. This is the question that we're trying to ask in our guard statement. Can this method start a workout right now? But that's not what the code here is asking yet. The question it's asking is still actually pretty vague. These 3 variables are describing the state of the object. They're intended to answer questions like whether or not the user is logged in. They weren't designed to answer questions about starting workouts. We can improve the code by referencing our lifecycle enum. The idle case happens to be the only one where we can start a workout, so technically the code we have here will work. But we're still comparing 2 values to see if they're equal, instead of asking a specific question about starting a workout. Here's another example of what I mean. Consider a collection of possible activity types. We have an activity type enum that enumerates running, walking, and yoga activities. There are plenty of questions that the activity type can help us answer. One of them is whether or not to start the GPS system. Let's say that we only want to use GPS for running workouts. So we check if our activity type is equal to running and turn GPS on or off. Eventually, we decide to use GPS for walking workouts too. So we update our first if statement to support walking. But we forgot to update the second if statement, and now our app has a bug because we won't turn GPS off when the user stops walking. When we check for equality between 2 enum cases, we lose the opportunity to create a single source of truth for state-driven behaviors. Let's say we wanted a hiking activity to support GPS as well. Wouldn't it be nice to have one place to go to make that change? Fortunately, Swift gives us a great way to make this happen. We can extend enums in Swift with new variables specifically designed to answer questions that describe custom behavior. The question we're trying to ask is whether or not our activity type supports GPS. We can extend our enum with a variable to answer that question using its own cases to customize the behavior. Whenever we're ready to add hiking, we'll just have one change to support GPS here as well. Once we start thinking about specific questions, we can start extending our enums to help provide specific answers. There are lots of questions we might want to ask our enums that aren't inherently answered by specific cases. Nothing about the name of an activity type specifies if it should support GPS. Adding an extension for that specific question is how we describe that custom behavior. The best rule of thumb here is that anytime a program needs to use state to answer a question, there should be an enum extension to help answer it. Let's go back to our lifecycle enum and extend it with a variable that answers the question if we can start a workout. We know the app should only start a workout in the idle case, so we return true there and return false for the other cases. Every time we add a state, it's tempting to use a bool instead of an enum. They're easy to create and simple to use. But even from just the first bool we define, it would have been better to use an enum. The purpose of the workout in progress state variable is different from the guard statement's question of whether or not it can start a workout. Having the enum gives us an obvious extension point when the states and behavior of the object need to change in the future. As I've been exploring state-driven development, I've been trying to always describe state with an enum instead of a bool. But sometimes I do still use a bool just to see how it goes. Every time I've gone ahead with creating a bool, I've gone back and replaced it with an enum. Enums are just a better tool for being specific about state and being able to answer a broad range of questions that depend on state. It's become a foundational part of how I like to write software. When we set the value of an enum, we're telling the object what state it's in. Our lifecycle enum is describing the states the object can be in. It's telling us that we're in the workout recording state, or the saving a workout state, or the not logged in state, or the idle state. Anytime a program enters a state, there should be an enum defined with a case to describe it. To complete our example, here's what using our new can start workout extension looks like in the guard statement. Our stop workout method also sets our lifecycle correctly to indicate when the app is saving a workout and when the app is back to being idle. We can keep extending our enum to describe more behaviors. We can ask the state for answers to questions like what the title of an action button is, or what the background color should be. In this example, the enum knows what the state of our lifecycle is, so it can return the correct action title for each state. It's important to be careful using default switch statements because the compiler won't warn us when new cases are added to our enum. We can also return different background colors for different states. Some switch statements benefit from using the fall-through syntax to return the same values for multiple cases. Fall-through requires the explicit use of the fall-through keyword as opposed to implicit implementations in other languages like Objective-C. So we have to opt into using fall-through, but I like this option and I've started using it more often. We can also extend enums with functions so that we can take different actions depending on the state of the object. Here we've defined an action taken method on the enum that accepts a reference to the view controller. The enum can then take advantage of the view controller's public API without having to know anything about its internal structure. The view controller exposes start, stop, and save methods that our enum can use. What's nice about this is the logic for what to do when the button is pressed is entirely encapsulated in the thing that describes the possible states of the button. All we have to do when we want to change behavior is change the options described by that enum case. Our view controller benefits from this encapsulation too, with a very clean ID action implementation. The real aha moment for state-driven development comes when we need to add a new case to our enum. We need to add a new state to support restoring a workout. After adding the new case, our switch statement prompts us to implement it in all of our extension variables and functions. That turns the enum extension into a public API for extending the behavior of our object. As long as we avoid direct case comparisons and the default switch statement, the compiler will tell us exactly what we need to change to support the new case. Now that we've covered the basics of state-driven development, I want to focus on a few features of enums in Swift and how they make state-driven development even better. Associated values are my favorite Swift enum feature. An associated value is basically a tuple that we can add to any enum case. We can access the value stored in that case's tuple whenever we need to. Here's what the syntax looks like for specifying that an enum case has an associated value. The enum case is workout in progress, and current is the parameter name of a workout object. When we want to get the associated value out of an enum case, we can do it with Swift's pattern matching syntax. Since the value is a constant, we have to use let to tell Swift to treat it as a constant. Slightly confusingly, all of these are actually valid syntax for obtaining an associated value from an enum case. The associated value can be used or not used. Its call site name can be used or ignored. And let can be after the case or inside the parentheses. It's important to note that when we use let after case, then it applies to all of the associated values within the tuple, which is actually pretty handy if you have multiple associated values for one enum case. These are all the same examples for the switch statement syntax, and all of these are valid examples as well. This is the syntax that I prefer using. The compiler auto-completes the call site name current for us, so all we have to do is hit enter and type a variable name. I like using let after case so that it applies to all of the associated values if I happen to have multiple. Here's what setting an associated value looks like. Back on our start workout method, we create a new workout object and pass it along when we set our lifecycle to the workout in progress state. We can use the associated value to help answer more types of questions by extending the scope of our enum cases. Here we're using it to return a different title based on our current workout's activity type. Associated values are highly relevant to the states of our objects. It makes a lot of sense to have the workout property live within the workout in progress case because that's the only state where our object can have an active workout. We can pass in the in progress workout's associated value to our save workout method to specify the workout that needs to be saved. Result is another example where having highly relevant values is useful. It makes sense that our result enum only includes error as an associated value on the failure case because the error is only relevant when there's actually been a failure. When we need to handle the failure, we have the error available to use within that context. Otherwise, we don't need to worry about it. Enum cases with associated values can help provide useful context. In this example, our table view cell has defined a protocol for the types of content it can display. Most of the content properties are optional though, because the cell can support showing an image without text or text without images. We can create a cell configuration enum with associated values to provide the context for when specific cell content should be used. And since enums can conform to protocols, our configuration enum will implement property getters for all of the variables defined by the cell content protocol and return the associated values specified by each configuration. With our cell configuration enum in place, we can define mapping functions on our model objects to return the cell configuration best suited for the data they need to show. What's nice about this pattern is that it keeps details of the data models outside the cell configuration. The part of our app that chooses how to represent a model object is basically reading from a menu and choosing what to order from it. I'll have a detailed cell with a workout title and an activity type description. Our self-heroic index path implementation is a lot simpler too, because we don't have to worry about performing any configuration here. When we dequeue our cell, we just get our model object for that row and set up the cell with the configuration that the type of model object specifies. And because our cell defined a protocol for its content, the cell doesn't need to know anything about the enum that implemented the protocol. It's just using the content that it was provided with. Enums can also be the single source of truth for complex objects like view controllers. There are usually several modes that a view controller can be in. The modes might be designed around features like viewing or editing a document or recording or saving a workout. A lot of things can change based on the mode. The navigation bar title and bar button items might be different. There might be an overlay view that's hidden or visible. There might be an activity indicator that's started or stopped. Reasoning about all of these appearance customizations can be a big challenge without a single source of truth that describes what they all do in each possible state. Think about a screen where the edit button toggles to become a save button, or a cancel button toggles to a close button based on the view controller state. I fixed an issue recently where I was showing the wrong navigation bar button items for the state the view controller was in. The screen was showing a cancel button instead of a close button because the navigation items were changing separately from where my view controller's state was being changed. A great way to fix these types of issues is to implement appearance customizations as a function of state. We can define a setup view function and pass in the state that we're transitioning to. The function can perform any necessary setup based on the requirements specified by our state enum. Other behavior is likely to change based on our view controller's state too. We might have different table view cell selection behavior for editing a document versus viewing it. We might also have a completely different data source to show in each state. At some level, everything about a screen depends on the state it is in. By moving all of this logic into an enum, especially a single enum that describes all the possible states that the screen needs to represent, we greatly simplify our view controller implementation and keep all of our complex logic contextual to where the states are defined. If we need to iterate through all of an enum's cases, we can conform to the case iterable protocol. When we conform to case iterable, Swift automatically implements an all cases property for us and keeps it updated when we add or remove cases. One thing worth noting about case iterable is that we do need to conform to the protocol in the same file that our enum is defined, or it won't work. We can also provide a custom implementation of all cases if we want to, which is important for enums that use associated values. Swift can't know all the possible associated values, so it will complain unless we provide our own implementation. The downside of doing that, of course, is we do have to remember to keep this updated if our cases change. Enums in Swift can also have raw values. Traditionally, most enums use ints as their raw values, but we can use strings too. This is really useful for defining things like keys that we want to reuse in multiple places. Swift can define the raw value as the name of each case automatically, or we can provide our own raw value for each case. Here we're defining a specific string for the selected activity type case, and that's the string we get back when we access the raw value. Support for string and int raw values is built into Swift, but because enums can conform to protocols, we can actually make an enum work with any raw value by conforming to the raw representable protocol. Here we have an application theme enum that defines different color schemes. The enum is defining the options, but there is a separate struct that is actually defining the values that our interface needs to configure itself. How can we combine these? This is actually a pretty good situation for using a custom raw value. We conform to the raw representable protocol on our application theme enum and make the theme struct into its raw value. Once we're done, we'll have direct access to the theme struct right from the enum case. Enums with custom raw values don't support associated values though, so we do have to pick and choose which approach makes the most sense for our use case. We could have decided to use associated values to solve this problem by initializing every case with a theme struct. But the problem there is we need to know which theme struct to pass in to create each case. And that's pretty hard to define and almost impossible to enforce correctness. And that makes the enum harder to use. Since there are trade-offs between associated values and custom raw values, I recommend looking at associated values first. If most or all of the associated values are duplicates, then it's a good indication that a custom raw value makes more sense for the use case. Another benefit of using a custom raw value is that it makes supporting case iterable easier since we don't have any associated values. The default implementation of case iterable works perfectly for our application theme enum and gives us back an ordered list of all of our application theme options from one variable that the compiler will maintain for us. I wanted to end this talk with something fun by sharing one of my favorite real-world enums that I've created. During a recent hackathon project, I added Easter egg confetti effects to the MapMyRun and MyFitnessPal apps. I used an enum to define the type of confetti we could show, including custom colors, images, or even emoji. We have some colors and emoji confetti moments pre-specified, and 2 additional cases for specifying custom colors and images. Each case just needs to return an effect scene for creating the confetti in SpriteKit. The confetti can appear whenever someone completes their diary in MyFitnessPal, or congratulates someone on a great workout, or mentions tacos in their workout post on Taco Tuesday. I hope you all enjoyed the talk. If you want to try state-driven development in your project, Just try creating an enum to describe the state instead of a bool. It's a nice rule that's easy to remember. And when you need to ask the enum a question, define an extension to provide the answer as a function of state. If you want to keep exploring enums, there are a few specific blog posts and articles that I've found very helpful in thinking about enums in my own work. These are a few examples on enum-driven table views and an awesome series of blog posts on pattern matching. And these examples focus on strategies that also improve code quality in Swift and have some awesome references for how enums can help you do that. Thank you very much. I hope you enjoyed the conference, and thank you again for coming to my talk.